Now let's talk about osmoles. So when we talked about osmosis, we talked about tonicity and osmolarity. So there are two terms, so osmolarity and osmolality. So let's talk about osmoles first. So osmol refers to, again, mole referring to the number of molecules, but osmol, no. So there can be multiple molecules that are dissolved in the solution, but osmoles refers to those solutes, those things dissolved in the solution that actually can contribute to osmotic pressure. In other words, this is the concentration of molecules that are actually attracting water. Now, multiple solutes can contribute to osmotic pressure. I did only show things like sodium ions or glucose or try to keep it simple. But the thing is that multiple ions, multiple solutes, even proteins, these contribute to osmotic pressure. In other words, the movement of water due to osmosis. So it's not just, so osmoles refers to the sum of everything. So for solids that dissociate, moles is not equal to osmoles. So things with sodium chloride, well, you have sodium and the sodium ions. Does that attract water? Yeah, it's positively charged. That will attract the slight negative charge on a water molecule. Whereas chloride ions, do they attract water as well? Yeah, the negative charge is going to attract the slightly positive hydrogen ions on the water molecule. So what we have here is that 1 mole of sodium chloride is going to dissociate into 1 mole of sodium ions and 1 mole of chloride ions. So now you have 2 moles of ions that are contributing to osmosis. Okay, so this is where I'm like, why the heck did they have to make it so similar? Like osmolality versus osmolarity. So again, I think whoever came up with osmolality and larity, when they were trolling or something, because why did they make it so similar? And it always takes me a little moment to think, okay, which is which? So if you worked in a lab, you probably worked with osmolarity. So this refers to the amount of, it's just like a molar solution. It's the amount of moles that contribute to osmosis per liter. So moles per liter. That's what osmolarity is. Now, the thing is that it also includes the volume due to solutes. So if you made a solution, you probably had like weighed out your ingredient in the lab. You probably like weighed out the ingredients and then added some water to make it to just below volume and then brought it up to your final volume. So the thing is that your solutes also have volume as well, even though they dissolve. I mean, the initial dry ingredients you put in, they do have volume. That does contribute to the overall volume of that solution. Now, osmolality, this refers to osmoles per kilogram of solvent. And again, it's not, this refers to mass, not volume. They are not one and the same. So the thing is that osmolarity and osmolality is around the same, but they're not quite the same. So think about osmolality. Now that you're weighing it per kilogram of solvent versus the overall volume of the solution, now you have, remember that in terms of like the amount of moles of solution, now you have a specific ratio of osmoles, solutes solutes to the solvent. So we're not talking about, now it's mass versus mass over volume. So the thing is that, remember that volume can change. So pressure, that can condense more mass into a smaller volume versus heat. That can also cause like a mass to be distributed over a greater volume. So osmolality, when we're talking about like base values or in terms of like reference values, osmolality seems to be used more in the clinic than in the lab. But again, why? Well, remember all the fluids, especially those in your circulatory system, they're always under pressure, and also things like body temperature, like a solution that was sitting at room temperature versus in the body. Well, when it encounters the heat of the body, that solution is going to expand very slightly. So this keeps the ratio of molecule osmolality, keeps the ratio of solutes to solvent more consistent because again, it's not being affected by temperature and pressure. So when you have the reference value referring to the milliosmoles per kilogram of water, it's actually referring to osmolality, not osmolarity. So this is the reference value I got from USMLE step 1. So this is just under 300 milliosmoles per kilogram, not liter, of water. And again, it has kilogram of solvent. But again, the main solvent in the body, water.